Back to Further Solutions Academy. Further Solutions Academy. Encourage us more to share and subscribe. Share and subscribe anywhere you see our video. At this presently, we have over 250 videos on our platform. It means you can come here and learn any topic of your choice without any problem. Don't forget, if at all you need to message us or comment on any of our video you are expecting, or there are missing gap, you can leave a comment below, or you call us with this number. You can reach us with this number. You can do three things with this number, which the first thing, you can call us, you can WhatsApp us, and lastly, you can via Telegram is allowed. You can do the three things there. Now, I have electrical energy and power for you on this video. By the end of this video, there are two outlines. The first one, electrical energy, which I will attach example with it, and the second one is electrical power. By the end of this video, you will understand this too, by God's grace. Now, okay, let me start from electrical energy. Now, we all know what is energy. Energy is ability, capacity to do work, and it's always measured in joule. You know what is called force. Force are very important at this point. Okay, which you have to watch our videos on those parts, which is static force and another. Now, electrical energy. Electrical energy. Now, electrical energy. It will be which is, let me denote it by W. It will be equals to quantity of charge, which is always by Q, multiplied by potential. Different, which is V. Quantity of charge multiplied by W. Okay. Now it means I can say that W equals to Q V. Let me call it equation 1. That is equation 1. QV. Now, we all know that my Q, which is quantity, which from here, substitute thing, Q equals to I of T, which we have done all this earlier. I of T. It means I can say my electrical energy, which is my energy, equals to IVT. IVT. We all know what my I is, we all know what my T is, and we all know what my V is, which is time, current, and potential difference. Now, since I have that one, I can now continue, which also I can say that my V can be equals to, which from Ohm's law. I've explained that earlier, from Ohm's law. It means my energy can be equals to I squared of T of R. Now, I squared of T of what? Of R, from Ohm's law. Please don't forget that. From Ohm's law. Now, if I want to do it, I can say that my I, which is my I, can also be equals to V all over R. Which I can also say that what? My W, which is my electrical energy, can be equals to V squared of T with the rate of what? Resistance. Now, these are equations that are useful in the field of what? This part. This field of electricity. Now, if I want to do it very well, okay, now, can I continue by having electrical energy Now, electrical energy is always equals to okay, what am I saying about it? Electrical energy can be calculated using any of these equation. Now, any of these equations, please take note of these equations. You can use this, and rather you can also use this. Take note of that information very well. Now, let's talk about electrical power. Now, when we talk about electrical power, it means I'm talking about we all know what power is saying anyway. Power is always a rate of work done with rate of time anyway. Okay. Now electrical power is always equals to electrical energy transfer, which is W, divided by time taken, which is always T. Okay, it means I can say that my power equals to W all over T. And I've been telling you earlier that we have all this anyway. And I can also say that we all know that let me substitute my W equals to what? Quantity of. Yes. Okay. Into. Now it means I can say that my power equals to quantity. This is V. Okay. Quantity V divided by what? T. Now we all know that my W also is equals to my W equals to IVT, which I can say that my power equals to IVT divided by what? T. What else can we say there? We can also say that my energy can also be equals to I squared of R of T, which my power can also be equals to I squared of R of T divided by divided by, yes, which implies I squared of R, because they cancel themselves. Now all these are okay. I can also say that I want to manage my board. Okay, I can also say that okay, what else can I say there? I can also say that my I equals to V with the rate of resistance, which my power can also be equals to V squared of R divided by R squared, which also implies V squared all over R. V squared all over R. All these things are very useful when we are talking about what? Electrical power. And now we can say that so electrical power can be calculated using any of these equation. Now, okay, what else do I need to? Let me just let you know that it means my P can be equals to of T can be equals to Q of V all over T, can also be equals to IV, can also be equals to I squared of R, can also be equals to V squared of R. Any of this can be used for what? A problem. Now, let me quickly define these terms. We all know, okay, let me quickly explain it because many people may not be able to get it anyway. I'm making to wrong everything. Okay. Now, where W is always called electrical energy, which is in joule, and also P, we call it electrical power, which is always in watts, and I, we call it current in ampere. Which is always in A. What else is there? We have V, which is called potential difference. Sorry, permit me to use that PD. In volts, which is V. What else is there? We have R, which is called resistance. In ohms. We have Q, which is called quantity of charge. In what? In coulombs, which is Q. What else is, okay, T is also there, which is time taken in seconds, which is X. Instead of this information, they are very, very important. Now, let's move on. Let's move on. Now, electrical is energy. We have mentioned this earlier, which is when we're talking about heat capacity, heat transfer, and so on and so forth. But this time around, I want to take, you have to take note of this. Electrical heat energy. Okay, electrical energy is always H equals to I squared R of T. This is arrangement with, I have to cut the board, with joule, lot of electricity, electrical heat, heating, which states that the heat energy produced in a wire as a result of electrical current passing through is proportional to the resistance of the of the wire. Yes, resistance of the wire. Now, resistance of the wire to the square of the current 3. This is 1, the resistance of the wire, and this is 1. The time taken. The time taken. Now, these are the things we are talking about here. Okay. It can be calculated by any of this equation. E equals to I squared of RT can also be equals to ID, can also be equals to B squared of T all over R, can also be equals to PT. Please take note of that information. Now, I think with this, you can see what we'll be talking about on this part. Now, let me try to give 1 or 2 examples on electrical power. Sorry, we are talking about physics. Let me cancel my physics. It's very important. This is physics class, not mathematics class. Physics class. Okay. Now, let me look for a problem that will really help us to illustrate the point. Now, a work of 30 joule is done in transferring 5 million coulomb of charge from a point B to a point A in an electric field. What is the potential difference between B and A? This is a very nice question that somebody can ask you anywhere. Now, how do I solve this problem? Solution to this question. I've told you that work done equals to quantity of with volts. Now, we all know that my V, I have my W, which is the work done, 30 joule, and I have the quantity, which is 5 million coulomb, and which also can be interpreted as Q equals to 5 multiplied by 10 raised to power minus 3 coulomb. And what else are we talking about? Now, it means from here, my V can be equals to divided by what? Quantity, which I'll be having 30 divided by what? 5 multiplied by 10 raised to power A. Million, no, this is power 6. So this is power 6, anyway. Now, it means I'll be having 5 here, 5 in 30, that'll be 30. 5 equals to 6.0 multiplied by 10 raised to power minus 6. That is my answer. That is my final answer. That's all. Another problem. question, calculate the resistance of the filament of a lamp rated 240 volts and 40 watts. Now, how do I go? I know that solution to this problem is a very simple one. My potential difference, it will be equals to 240 volts. My power, it will be equals to 40 watts. Now, it means my power equals to V squared divided by resistance, because I'm to calculate the resistance. Now, it means my resistance will be equals to V squared divided by what? Resistance. Divided by power. Everything will be in ohms. What is my, I think I have 240 divided by 40, which is, we're talking about resistance, which cancelled, and I'll be having 24 and 4. 20, that'll be 5, that'll be 6, it will be 6 ohms. That's all. That is very, very simple. I will solve. There are simple ones that you can see your objective anywhere. I have this question also. The maximum power dispensed by a resistor in a circuit is 40 watts. Calculate the voltage across the resistor. Now, what I need to do is that solution. I'll be having we have my power, which is 4 watts. I have my resistors, which is my resistors. Okay, what will be my resistors? Now, my resistors is not now the maximum resistance discharge, it will be 100. Because of this maximum, it will be 100 ohms. Now it means my power equals to volt squared divided by what? Resistors, which I'll be having V equals to volt squared divided by resistors. Now, okay, yes, because you are looking for volts. You are looking for volts. Now, it means the maximum is spent by the resistors. Okay, across it. Now, it means I was talking about V squared equals to PR. It means my V equals to whatever I have of P and R. I'll just put the numbers and go. That is all. That is all. Now, I think it's getting better anyway. Another problem, let me make this one to be tedious so that we'll be able to help us. When connected to a mains of 250 volts, the fuse rating in the plug of an electric device of 1 kW is okay. Now, what I do here is that my P equals to 1 kilowatts, which is entering as 1000 watts. Now, my V is equals to 250 volts. Now, my P equals to IV, which my I equals to P all over V. And whatever you want to do, you will have it, which I'll be having 1000 divided by 250. And whatever you have, that is your answer. That's your answer. Okay. Now I have this connection. I have this circuit rather. It flows this way, it flows this way. Now 2.5 ampere. This is 4 ohms. This is 4 ohms. Now calculate one, the rate of energy consumption. 2, the total energy developed in 15 minutes in the circuit. Illustrated. Let me just put illustrated by the above. Now, solution to this problem. These are just now what I need to do, the rate of energy consumed or consumption will be equals to power used will be equals to power used. Now we all know that my power, it will be equals to IV, which also V squared of R, which I can answer that P can be equals to I squared of R, which I'll be having 2.5 squared because my current is 2.5 multiplied by this is the series. Let me quickly part this one is series. It will be 4 multiplied by 4 divided by 4 plus 4, which is equals to 16 all over 8, which is going to be 2 ohms. Now it will be equals to 2. Now we have been on this all the time. I know I don't need to stress myself again. It means it will be equals to 2.5 squared multiplied by 2, which I'll be having 2.5 times 1.5 12.5 watts. That is what I'll be having. Because my high, don't forget my high from the question is 2.5 ampere. That is all. That's okay. That is all for that number 1. Number 2. How do I get number 2? We are looking for the power. We are looking for what? Number 2. We are looking for the total energy developed in that time. It means I have my current. Number 2. My current is 2.5 ampere. That's the first thing I will do. And my resistance, total resistance is 2 ohms. And also, what else did I do? My time is 15 minutes, which I'll be having 15 minutes. It will be 15 minutes, which it will be 900 seconds. Please take note of that. It must be in that time. It means I can answer that what my total energy developed, which is I'll be equals to, which is going to be square of r of t, which I'll be talking about h equals to 2.5 squared multiplied by 2 multiplied by 900, and whatever we have with help of calculator, which you'll be able to get something very good, which I'll be talking about 11,250 joule. That is my final answer. Okay, I think from here, with what we have achieved so far, I think you can handle this part of electrical energy and power. Don't forget you are on with further solutions academy. I encourage you also more to share, and if you have not subscribed, make sure you subscribe to this channel. Make sure you subscribe. To meet us, or to leave a comment, you can leave a comment below, or you reach us with this number. With this number, you can do 3 things with, which is call us, you can WhatsApp us, and via Telegram is also allowed. Once again, thanks for watching.